Hi there, this is L'Hopital's rule, and what we're going to be talking about is indeterminate power functions. And, well, basically, let's just discover what the form should look like. So, basically, we know that the general form of a power function is going to be, as x goes to a, you're going to have f of x to the power of g of x, okay? And one thing that I want to just walk you through three possible forms that will merit an indeterminate form, or can merit it, depending on how you do it. So f of x equals 0, and you'll have g of x, which will also equal 0, and this will come out to a 0 over 0 power, which, go ahead and use L'Hopital's rule. If we just take that same logic and have f of x equal infinity and g of x still equals 0, once again you have infinity to the power of 0, which, back in the same boat, indeterminate. What if f of x equals 1 and g of x equals infinity? A lot of people have problems with this one, but this can actually also be an indeterminate form. All of them, you just want to bring it back. Okay then, so let's just do a couple examples of this, right? Just like we've been doing. You'll have, let's say, this function right here. This will be good. X goes to 0. As x goes to 0, you have a function that is 1 plus sine 4x, all to the power of cosecant x. So I know what you're thinking. Well, yeah, I mean, this does hit the form, but this is part of the general form. At least we know it's a power function, but is it the right form? Well, 1 plus sine of essentially 0 is going to equal 1, and cosecant, which is 1 over sine, okay, well, that's going to equal 1 over infinity then. So that would be correct. That's 1 to the power of infinity. Well, we know that that's, good grounds to be in. So let's just work it out, right? One thing that I always recommend people to do when they are doing power functions, it's completely, well, it's a little bit different. There's a bump in the road. And it is that I want you to make everything to the natural log of it. So I want you to put natural log on both sides of the equation. So realize that really what function we have here is essentially like a limit as x goes to 0, you have y, is equal to the limit as x goes to 0, you have your function, which is 1 plus sine 4x cosecant x, right? Well, let's just put ln on both sides. You have ln of y and ln of this entire function, which is huge. In this function, we have 1 plus sine 4x all to the power of cosecant x. Okay. Well, I don't know if you can recall any of your log rules, but what we have here is we have ln y, and I just put it out there just to remind you that you're not solving for y right now, you're solving for something else. what you can do is you can actually pull that power, this power right over here, the cosecant, and since it's a natural log, you can actually multiply this value by it to get, essentially you just pull that up front. It's the same thing. Multiplied by ln 1 plus sine 4x. And I know probably some of you can't really remember that you can do that, but anytime you have a natural log, you can just multiply that function by its power rather than, the other way around. And that's how they work, and I actually encourage you to go back and review your algebra notes and that. One thing I do want you to notice, though, is that when you're looking at these two, and remember we are looking at a limit as x goes to 0, what you'll see is that we have infinity times 0 form. Which is kind of cool because, hey, that's what we need for products. And this is essentially a product right now at this point, right? So you can kind of see that on our way, it's just kind of a journey. What do I always like to do, though? I always like to break it down into a more simple form. So let's take that cosecant and make it 1 over sine and multiply them together. So what you should have is ln 1 plus sine 4x all over sine x. Remember, cosecant is just 1 over sine. So you can kind of see how now we've transformed this into a quotient form. And all you do is you just look at it and you say, well, this is L'Hopital's form. It's valid. It's 0 over 0. Let's just do it. So we take the derivative of both the top and the bottom. And let me just do the math for us. Ln 1 plus sine 4x. And when you take the derivative of that, what you're going to have is, first of all, let's just take the derivative of the entire function, the natural log. So that's 1 over 1 plus sine 4x, right? Then, because of the chain rule, you have to take the derivative of what was inside the parentheses, which is just cosine 4x, right? And then you take the derivative of what was inside those parentheses, which was dx. It's just 4. 4x. So it's just 4. That's all you'd be multiplying it by. So the chain rule, 4 cosine 4x all over 1 plus sine 4x. And trust me, like, I guarantee you that within at least the last like 3 or 4 problems, I've made an error somewhere in my video. So even on some of the basic stuff like cross products and everything. So trust me, like, if you make an error, do not be discouraged by it. Just, try and pay attention. All of us got things going on around the house. I mean, my neighbor, I don't know if you can hear it, but he's opening and closing his garage door, which is shaking my whole house. So, I mean, just try and get, I guess, appropriately situated whenever you have your layouts. So, let me do this real quick. We have the natural log of y will equal this whole function, which is going to be a nightmare of a function, 4x 1 plus sine 4x all over cosine x, right? Which, if we simplify that out, This will equal 4 cosine 4x all over cosine x and 1 plus sine 4x. Okay, so why don't we check to see what that is? Well, if we were to plug that 0 in, what you'll find is you'll have 4 times 1 all over 1 times 1 plus 0. Okay, so now we know that we have 4 here. Y equals e to the 4. That is your solution.